Assalamualaikum, this is Adalisi, Network and vSphere Administrator and Virtual Instructor of Cisco and VMware Technologies at NanoTechX. Today's session 10 started now, and let's start after 1 minute, and let's wait for participants to join the meeting. So we have only 1 minute left to start the session because we are waiting for participants to join first. So up to that, let me open the lectures in 1 minute. So we have only 20 seconds left to wait for them, then we will start. So yesterday, let's start now. So yesterday we have talked about this diagram in which we have covered about permanent data storage devices and temporary data storage devices. So we have covered up to NVRAM, and today we will cover the last topic in real life examples of hardware. Then we will move to next topic. Okay. So today's topic is about USB. USB. So let's talk about USB now. But before that, let me show you one thing. So there are four types of basic devices. First is known as standalone device. Second is known as end device. Third is known as intermediate device, or we can say network device. And the last one is known as the mobile media device. So let me first make you clear on these points first. A standalone device means device which is not connected to any network. First I want to define these in the short definition. So the first one definition is the standalone device mean device which is not part of network, or we can say which cannot be connected to, or which is not connected to any other device is known as standalone device. But if you talk about end device, device which can send and receive traffic is known as end device. Means which device can send or receive the traffic that is known as end device. But we talk about intermediate device. So device, first let me load the member, and this is the chat box where you can ask the question. Welcome Ishtiaq Muhammad from India, and we welcome you in the session. And kindly you can ask the question in the chat box and mute your mic, please. Now let's continue. So what is intermediate device? Device which can forward traffic is known as intermediate or network device. So device which can forward traffic is known as intermediate device, or we can say network device. Because to this device we can connect n devices. So the last one is device which we can insert and remove into n device or standalone device is known as removable media device. Now let me give you an example. Standalone device means, for example, my laptop. Not now. For example, I turn off Wi-Fi, so I have no connectivity to connect with all of you. So my laptop would be standalone device. But if we talk about end device, so now on this time, currently, my laptop is end device. Why? Because now I'm communicating with you. I'm sending my traffic in form of a voice to you and receiving some text messages in chat box from you. So my device is end device which can send and receive traffic. And if you talk about intermediate device, let me show you intermediate device here. Kindly look at this. I'm going to show you in my video camera. You can see here, and I'm going to pin myself. Look at this. As you can see, this is intermediate device. Why? What is the reason? Because through this device, I'm connected with all of you. This provides me wireless connectivity because this is wireless device. It have no cable plugged with my laptop. This is just a charger. We charge this device. And you know that through wirelessly I am connected with this device. So my laptop is connected to Wi-Fi through this device. So this is known as intermediate device. Why? Because it forwards the traffic. Now I'm talking to you. So my voice is reachable to you. Why? Due to this device. Why? Because my device's laptop is just an device which sends the traffic. But this device forward the traffic. If this device is not available, it means I have no connectivity. My laptop is not a device, that is standalone device. And you know standalone device cannot be part of a network. It cannot send or receive the traffic. So that's why because it is not connected to any intermediate device. So any device can be connected to intermediate device like I've shown you. Thank you so much for watching this device. Now let's move to the screen and now focus on the screen. Okay. So this was just the practical example of intermediate device. This device is known as wireless mobile device, or we can say mobile Wi-Fi device. In the basic terms, if we describe it, so it is known as access point. We can say wireless switch because I'm connected to this intermediate device wirelessly, not through wire. Okay. So now I'm going to unpin myself, and now let's move to screen. And this is chat box. You can ask any question you have. There is the question from Shansali. To which type does node belong? Node means device. It can be of three types. Which one? First is known as end device, second is known as intermediate device, and third is known as standalone device. I've also described about node in the session number 3. You can watch it. We have discussed about it in deep and dive. What is node? So you can watch my previous session, session 3 basically. So removable media device mean device which can insert device which we can insert and remove into any device or standalone device. That is known as a removable media device, like for example floppy disk, like for example USB, like for example CD. For example, let's take the example of CD first. You can open the CD-ROM and you can insert the CD in the CD-ROM, or we can say CD disk, and then you can remove. So that is known as media device, removable media device. But for example, let's take example of USB. You all know universal serial bus, and we are also going to talk about universal serial bus in detail as well now. after a few seconds. So how USB is removable media device? Because we can insert USB in our device and we can remove USB from our device as well. And if our device is standalone, it is not connected to any network. So there is no standalone and we can insert USB in standalone and remove from standalone as well. But if we talk about any device which is connected to any network, if it have wired connectivity or wireless connectivity, so we can insert an end device as well, and we can remove USB from end device as well. So that's why I have written here end device and standalone. Okay, but I haven't written intermediate device that we cannot insert or remove by media device from intermediate device. It can be in some situation, but mostly it doesn't. So that's why I haven't mentioned. Like for example, let's take example of switch and router and firewall. These are intermediate devices. So can you tell me that can we plug in or remove the removable media device from intermediate device? Is it possible? No. So that's why I haven't mentioned. There's a question from Ishaq Mohammed. What is IoT devices? Okay, Internet of Things. So these are also devices which are basically termed as end device. Why? Because that can be connected to any network as well. But for example, we talked about standalone device. So that is not IoT device. Why? Because it cannot be connected to any network. It cannot be a part of a network. It cannot communicate with another device. So that's why it is not IoT device. And removable media device is also not an example. Just we can say end device. End device. Why? Because it can communicate in a network. Intermediate device which can forward the traffic. So that was it. Now let's talk about USB. But before that, let me show it first. I will share these notes after this session. Now let's talk about universal serial bus. Okay. So the first point is that USB stands for what? So let me take the answer from all of you. USB stands for what? Let me check what is your answer. Then I will tell you that USB stands for what. So USB stands for USB stands for Universal Serial Bus. So you should remember this, okay, which is the basic term. Universal Serial Bus. Let me write it here. Universal Serial Bus. So it is used to connect with PC for sending and receiving of files. You know, it is removable media device. Like you can plug in and plug out this device from any device or standalone device. But this is used for sending and receiving of files. Like how? For example, I attach USB in my laptop, which is for example any device. I'm connected to Wi-Fi, any network. So we can send the files from USB to our computer. So that's why we can say it is used for sending of files. But we can receive the files in USB as well. Like how? I want to transfer some files from my laptop to USB. So yes, it is possible. So that is receiving of files for USB, but sending from laptop. It is a device used for saving data on permanent basis. And in USB you can save data on permanent basis. But its file system is not known as permanent file system. Its file system is known as temporary file system. Why? Because when you plug in USB, so it is just for a while, not for permanent basis there, because it is a removable media device. It can be plugged out. So that file system is temporary for my laptop, temporary for my node, temporary for my end device, temporary for my standalone device. So that's why its file system is temporary. But data which is saved in USB is based on permanent basis, not on temporary basis like RAM. So that's why That's why we can say it is secondary storage device. These are some USBs you can watch. So the first one point were USB stands for Universal Serial Bus. Another point is what? Another point about USB was what? If you remember that it is what? It is which kind of device? Like I've also described four type of devices. So it is which type of device? If someone asks you. So this is removable media device. Okay. Another thing is about file system of USB. And what is the file system of Universal Serial Bus? So what would be your answer? So the answer is that its file system is temporary, but data stored on USB is on permanent basis. So this is the answer. Data stored in USB is on permanent basis, but its file system is temporary. Data stored in USB is on permanent basis because it's not RAM that when the computer is on, data would be available. Computer is off, data would not be available. It's not like that kind of thing. That is secondary device. But due to its removable media device property, its file system is temporary. Why? Because removable media devices can plug out from your device. So that's why its file system is temporary for your device. So that was all about universal serial bus. You talked about it in very detail. Now let's move forward. And you know that finally these 10 examples of hardware we have finished in deep and dive, and this topic is finally finished here. I think in 3 to 4 sessions, only this topic in lecture 13. So it means this was too much important for the basic students because we have covered each and every point in these topics in detail, in very depth. And if you want to know that how in depth, let me show you. We have started from RAM and finished on USB. Let me show some notes about it. Look at this first. We have started from this one, RAM. Look at this. And now count how much notes we have covered. And we have finished up to this. So it means these were a lot of notes and not just these notes. Other notes as well, let me show you. Note these, okay? Look at this. We have started from RAM, okay? So this is what RAM. So we have started the notes from this one, this point, and now count. It's mean up to this point, we have covered the real life examples of hardware in depth. So these notes and plus the previous notes I've mentioned. So we have covered the real life examples of hardware as I've shown you now in very depth. Not like this that some trainees make you clear on these real life examples of hardware like this. RAM stands for random access memory, it is temporary memory. ROM stands for read-only memory, it starts the BIOS, etc. And CPU is just for execution. Motherboard is the motherboard not like this kind of thing. This is just a training for the basic people who don't know about networking, etc. Who don't know about system administration. So this is a very basic training, okay? So that's why we have covered each and every point in very depth, not like other trainings that just defines you. We have covered in every term of life. Like we have covered each hardware example in form of software as well. Like we have described each type of hardware in on-premises solution, in virtualization solution, in cloud computing solution. Okay, so no one will train you on these examples like in depth we have trained you in the previous 2 to 3 sessions, and now it is finished. So now let's move forward. Real life examples of software. Now we will talk about real life examples of software. But before that, you should know the software have two types. First, second. First is known as system software, and second is known as application software. So what is system software? It is used to run a computer hardware. It is used to run a computer hardware. The spelling is not good, not okay. So make it correct when you write a notes. So, system software is software used to run a computer hardware. Like how? It is a software which tells the computer hardware what to do. Without system software, computer is a dumb device. Why? Because if computer doesn't know what to do, then how it will work for you? So that's why the system software is compulsory to be available in your hardware. Remember this point. So before describing some examples, let me move to this point and define the second type of software, which is known as application software. So it is application which is run over a system software, like for example operating system, to perform a specific task for a user. Now understand. Now look at this first. For example, you have bought some hardware. For example, you have bought one hardware from market, and you install system software known as, for example, operating system, which is the example of system software. Now, why you install operating system? You know why? Because it is system software, and system software tells hardware what to do. So it just tells the hardware what to do. Okay, but the problem is that what it will tell. The problem is what it will tell to hardware to perform. So for that we need another level, which is installed on the system software operating system, known as application software, or we can say application simply, or we can say app as well, or package as well. So now remember, what does it do? It is used to tell the operating system that tell to hardware that do this task, because you know operating system operate the hardware that you should do this task, but operating system don't know what to do. So application software can't him do this, and operating system command hardware do this. So that's why you take an output in form of display unit like monitor or LCD or LED. And you know, in application software, you give some input as well as an instruction to operating system that tell to hardware to do this. Like through keyboard or through mouse, you click, or through keyboard, you press the key and enter the information about what do you want. So when you enter something, that is known as data, and when you takes output, that is known as information. So you need information. For information, you give data as an input. So application software is used for a user to perform a task. So how I've described in detail. Again, let me explain. It is application which is run over system software operating system. Look at this. It is installed on the operating system to perform a specific task for user. User will tell in application, like for example, he will give input in form of data and will take output in form of information. How? It will tell to operating system to do this. Operating system will tell to hardware to perform this task. Okay. Now let's move forward, and now let's talk about examples of system software like Mac operating system. like Linux operating system, like Android operating system, like Windows client operating system, like Windows Server operating system, like game engines, like search engines, etc. etc. And let's talk about some application softwares as well. Like MS Office examples are MS Access, MS PowerPoint, MS Word, MS Excel. And except of MS Office, GNS3 like network simulation software to perform a specific networking labs like routing labs, and Cisco Packet Tracer for performing network simulation tasks like performing basically the switching labs for the user, and pen software like this one. This is pen software in which I perform some tasks to make you clear on some points and to make notes as well and to make slides as well. And notepad is this one in which you write some information, like for example I want to create my timetable, so this kind of thing in which you write something, etc etc. So this is lecture 13 finished here. Now let's start the next lecture 14, but before that let's come here and we will talk about this in next session from this point, okay? And we will start lecture 14 in next session. Now we will perform some labs in GNS3 and packet tracer. One lab in GNS3 and one in packet tracer. So before starting the lab, I am available here to answer the questions if you have. So now it's the time to ask some questions. If you have no question, you can say clear, so then I can proceed to start the labs. So you have only 30 seconds to question or say clear, so then I can proceed to the labs. There is the question from Ishaq Mohammed. What is it, sir? What does it mean? I haven't picked your question. Can you please repeat the question? I mean that if you have any question, you can say, or you can say clear so we can proceed to the labs because we are going to perform some labs, some basic labs for the beginners. We can proceed, sir. Thank you so much. If you have any question, you can ask in chat box. So first of all, we will perform a lab in GNS3 network simulation software. Then we will perform a lab in Cisco Packet Tracer. So first we are going to open the GNS3 network simulation software. So now it's opened. First of all, we will create a project. So how to create project? Click on this option and here come and write here that two routers in a network. What does it mean? It means that we should connect two routers. Network means connectivity plus communication. So we should connect routers, okay? And then we should try to communicate to routers. So this is our task in the lab. This is a very basic lab for the beginners. Okay? So how? Click on this icon, and I haven't any router. First, I should install a image of the router, then I can pick up the router, else I cannot. And now I think we are okay to do a leave. Okay, so this is router 1 and this is router 2. First, let me connect them, then we will communicate them. So connectivity is done now. Now let's make them to be able to communicate with each other. So then it would be a part of network. Now they are not part of network, remember, because now they are just connected, and we know that network means devices are connected for communication. So now they cannot communicate. For communicating, we should try something else. How they should be communicated? Let's know. First of all, click on this icon, which means to start all nodes, all devices. I already told what is node. Node is in device. It can be intermediate or it can be end device. It can be standalone device as well, but not removable media device. Now let's show interface labels like fast Ethernet 0 by 0 and fast Ethernet 0 by 0. Let's click on taking control of these devices, and we have took control of these two routers. And now let's start. So first of all, I configure terminal and do show IP interface brief. Write this command first to check that is IP address or logical address is assigned to this port or not. Because through IP you can communicate with each other. Because router is layer 3 device and on layer 3 device we use IP protocol. So IP protocol is compulsory on router to assign because without that you cannot communicate with another router because router is layer 3 device and IP is layer 3 protocol, that's why. So how to assign IP to this port? Write here interface, write the name of interface and write the number of interface and press enter. Then you can see here you are in configuration interface mode. Right here IP, right here address, right here the IP which you want to assign. For example, I want to assign the class B private network. So how? 172.16.0. So two octets are for network and two octets in class B are for host. So obviously the network, these both are the part of one network, so that's why the network should be same. So you know that for the private network, its range is from 172.16 to 172.31. So let's choose 172.18 for example and .0.1. And let's give the subnet mask which means 255.0.0. It means that the first two octets are for network and the last two octets are for host. And press enter. IP is assigned and you know that this port is down by default because it is routed port and routed port is always down by default, so we should make it up to communicate through this port. So no shutdown, and now you can see the message that this port status are now up. Change state to up from down. So Let's come out from the configuration interface mode and let's come to configuration mode. So what IP we have given 172.18. So we should write it here for our information that we should not forget it. That's why. And to this device we should go like the network should be same class B. First two bits are for network 255.255. It should be same. But the 0.0, the host should be different. Like for example, I give 2. So the network is same 172.18.0.0/16. 16 means the first 16 bits in this IP4 this represents the network of class B. And this is private network, remember. So click on this device and now again the same process as I've done with router 1. Right here configure terminal to go from privilege execution mode to configuration. Configure a global configuration mode and right here to show IP interface brief. So you will see here the report that on this first Ethernet 0 by 0 there is no IP assigned, unassigned IP address. So how? And this port is down, status is down, protocol is down. So how to do this now? But before that, check here the report as well. That the port is up and the IP is assigned or not. Yes, the port is up, protocol is up, status is up, and the IP is assigned. And now do this here as well. How? Right here interface. What is the name of interface? First Ethernet 0 by 0 is the interface number, and right here IP address, and right here the IP. So what is the IP? I mentioned 172.18.0.2. What is the subnet mask of class B? 255.0.0. And that's it. And say to this port that now shut down. Always be up for the communication. And now as you can see, we are from global interface mode to global configuration mode. And the port is also changed state to up from down. And you can look at the report as well. Look at this. Protocol is up, status is up, and IP is assigned. And now there is the last step in the step that we should check that this router is able to communicate with this and this router port is able to communicate with this router port or not. If yes, then our network creation of network, which is known as networking. Networking means process of creating a network, so it is successful. But if no, it means that they are just connected. They cannot communicate, so they are not part of a network. This is not network. So our lab would be unsuccessful. So now let's check. For checking, we use the ping protocol ICMP. So write ping and address of this router. Fast Ethernet 0 by 0 port. So what is the address? This is the address right here. But we should write do because we are entering the privilege execution command and the global configuration command. So we should write do before that. So now as you can see the result here, that our communication is 100% successful. 5 packets sent and 5 received. And let's check here as well. Right, do ping and the IP address of this port. What is the IP? 172.18.0.1. As you can check, 5 packets sent, 5 received. Let's make communication is successful. So we have performed networking task. Networking means process of creating a network. So we have completed the process of creating a network in which we have done two tasks: connectivity through cable and communication. So both are successful. So these two routers are part of a network, and that's it. This was our first lab in GNS3. Now we are going to start the second and last lab of today's session in Cisco Packet Trace. Node main device. It can be intermediate device, standalone device, and end device. If you have any question, you can ask. Okay, I will appreciate. Now let's open the Cisco Packet Trace and Network Simulation software. In today's session 10, session 11, session 12, 13, 14, 15. It's mean that before New Year, our bootcamp would be finished. Let's wait for the Cisco packet tracer to be opened and then we'll perform a second lab. In this lab, what we will do, let me first give you a design, then we will start performing lab, okay? So the design is first go to network or intermediate devices, go to router. Like for example, I am taking this one router, okay? And come to network devices and take some switches. And now take some end devices as well. And what is our task? Our task is like this. First of all, let me arrange this first, then I will describe what is our task. For example, this is a company A, and this is a company B. And for example, in this company there is one switch, sorry, there is one router, and in this company there is one router. For what? For going into different network. And these are two switches used for connecting some devices. And here in this company there are two switches to connect some devices in the local company. So our task is that we should also communicate these pieces through switch with each other as well, and we should also try to communicate these devices in the different network, in the different company devices, like with these as well. And the same task will be performed with these devices as well. They should also be able to perform communication with each other in this the local company through switch, and they should also go through gateway and through router. They should go and communicate with these devices of another company as well. So this is our task, and now let's start performing. First step in what is networking? Networking means process of creating the network. So we will do networking in this lab. We will do what? We will do networking because Cisco Packet is networking simulation software. And networking means to process of creating a network. So we will do networking means we will do a process in which we will create a network. And there would be two networks, one network in this company and one network in this company, and we will connect these two different networks. And after this, they should also be able to communicate with different networks devices. So this is our lab, and first step in this lab, remember, when you do networking, when you do a process of creating a network, first step is to connect them, because connectivity plus communication is known as networking, a network. So that's why process of creating a network is known as networking. So now we are doing networking, but to create a network, there are two steps. First step is connectivity, second is communication. First, we should make them be able to connect with each other, and then we should try to communicate them. So that's why our lab will be successful. So first step is connectivity. How? Come here, click on connections, click on this automatic. Why this message? There is a reason. Because we should turn it off and give it some ports because it have less ports. That's why. And we should do with this router as well. Turn it off and give it some ports, extra ports to pair it, and now turn it on. And now try, it will work. Yes, finally it is working. As you can see, it is connected. So the first task is that this network should be like, for example, what I say, this should be a private network. Like for example, we say 192, like class C 192.168. So in class C there are three octets for network and one is for host. So network should be same. So here from zero, the third octet is from 0 to 255. So for example, we select 0.1 here. So here this PC IP would be .2, this PC IP would be .3, this PC IP would be .4, this PC IP would be .5, this PC IP would be .6, this PC IP would be .7, and this would advance one network, this company private network for its private communication, for its own machines communication. There will be a private network as well. Like what, for example, I take class B network, I think. So class B private network is 172. There are first two octets for network, so that would be same in our network, but last two octets are for host, so that can be different. So it starts from 172.16 to 172.31, I think. So we should take like 172.19, I think. That 0, that 1, and here we should say that 2, here that 3, dot 4, dot 5, dot 6, dot 7. What is the operating system used in CLI for of router in GNS3? Okay, that was the Cisco router, but 7200 model. So that use iOS Internet Network Operating System of Cisco. And another question is, which is more user friendly, Packet Tracer or GNS3? Both are best, but it depends on which lab you are performing. If you are performing the switching lab, so I will suggest it Packet Tracer is best. But if you are performing the firewall or router lab, then I would suggest GNS3 is best and easy to use. Both are easy to use, but Packet Tracer is little bit friendly for the beginners, but GNS3 is best for the advanced level. And now I've took the question. Now, if you have any question, you can also ask, and we will appreciate. Now let's perform the lab. Continue the lab. Okay. This is your box. You can ask any question if you have. Okay. Are they both same router iOS and Linux? No, 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 no. Linux is operating system for end devices, like for server clients, etc. And a router iOS is the Cisco operating system for intermediate devices like router, switch, firewall, etc. Not same architecture. There is used for intermediate device and the Linux is used for end device. Now let's continue. So it is also a network. So we should give some IP, and there should be internet connection between both companies to communicate. So internet, in internet we doesn't use private IP, we use public IP. So there should be some public network. Like for example, I take 9 class A. So class A have one network and three the last three outlets are for host. So the first network would be same and the host would be different. So 9.0.0.1 and here should be 9.0.0.2 for example. And now it's done. Connectivity is completed. Now let's go through communication. How? First, give them IP. How? So learn the steps. Go to the start, go to IP configuration, and right here, what? 192.168.0.2. And this is the subnet mask of class C. And what should be the gateway? Gateway means that 0.1, this one. Why? Because through this gateway, through this way, this PC can go in different network. Like this is now different network 9.0.0.1. Then it can be communicate with another company, another device. So that's why this is known as gateway. So we should show gateway to all devices which want to communicate in different network and different company devices. So we will show gateway to all devices. Okay, remember this point. What is the IP address of this device? 0.3. And the file gateway, this one. And this here for 0.4 IP. This here D.0.5 IP. This here 0.6 IP. And this here 0.7 IP. Because these are 6 devices, so that's why .7. One is for gateway. And now let's do the configuration of these end devices of company B as well after configuring the IP addresses of what end devices of company A. These are end devices. Why? Because they can communicate in the network. They can send and receive the traffic, but these route switches and routers are intermediate devices. Why? Because these forward the traffic from one device to another end device. So let's give them IP as well. How? So 172.19.0.1 is the gateway in this network to go through different network. So we should write 172.19.0.2 and 172.19.0.1 is its gateway. We can say default gateway. 0.3 and another device 4. This device 5, 0.5. This device have 0.6. And lastly this device have 172.19.0.7 IP address. And it's all done. Now let's configure these routers as well. How? Go to this router, go to CLI, with CLI, iOS. This is command line interface, not GUI, of which operating system? Cisco operating system for its intermediate devices, because 2621 is the model of Cisco. So that's why this router have Cisco operating system known as iOS, Internet Operating System, and it's CLI based. We can configure it by giving commands, not by clicking. It's not GUI. So right now, write enable, let's configure terminal and check exports as well. Do show IP interface, brief, and you can see here that no port have IP, no port state is up, no port protocol is up. Now let's try to configure how. First, look at this port. What is the name of this port? As you can see, interface fast Ethernet. What is the number? 0 by 1. Okay. Give IP address. What is IP address? 192.168.0.1. What is the subnet mask of class? 255.255.255.0. And set no shutdown because it's routed port to which we can assign IP and it's by default shutdown. And which port is shut down, then you cannot communicate through that port. So if you want to communicate to this port, then you should say no shutdown. Always be up for communication. So now as you can see, this port is up for communication. Change state to up. And now let's UIP. Look at this. First it was red. Now it's green because it's up. First it was shut down. Now it's shut down. Now you will see it would be up. How? Look at this. Right here interface. Right fast Ethernet. And what is the port number? 0 by 0 as you can see here. 0 by 0. Give it IP address. What is the IP address of this port? And there is a problem as well now. Which problem? The problem is that I have connected it in the wrong way.
Aisha, come here. Sleep. Sleep.
Now it's okay. I have connected it in wrong way. Sorry for that. I just forgot about this. Now let's move forward and let's continue. Okay. There was just my mistake. I will just clear it. Now let's move forward. So the another port is this one, which is now down. So right here interface Ethernet 1 by 0 and write IP address which is 9.0.0.1 and class A subnet mask is 255.0.0, which means first octet represents network and the last two octets represents host bit. Same no shutdown, say the port no shutdown, and now it's up as you can see. Right here do show IP interface brief, and as you can see these are up and the IP is assigned to both ports. And now let's come to this one as well, which is red, now not green. How to make it green? To make it up. For making it up, we should say no shutdown. Right here enable, right here configure terminal, and right here first do show IP interface brief. So no IP is assigned, status are down, no protocol is up. So right here interface name is fast Ethernet 0 by what 0, and here's the spelling mistake. And let me allow the member first. If you have any question you can ask. Okay, thank you very much. Always welcome Shansarin. Chat box is open for all of you. You can ask any question if you have. So we came in this port fast Ethernet 0 by 0, and now give it IP. IP address is what 9.0.0.2 class A subnet mask 25.0.0.0 and set no shutdown. And first look at this. These both are red. And after saying no shutdown, look at this. After saying no shutdown, look at this. Both are green because both are up for communication. As you can see here, the change. And now exit from this and write interface fast Ethernet and 0 by 1. What is the IP address of this port? As we have written 172.19.1 and class B subnet mask is 255.0.0. First two tests for network, last two tests for host, and say no shutdown. And check the result as well after configuration. Look at this. Up, up, up. IP is assigned. Status is up, up. And look at this as well. Up, up. Protocol are up. Status are up. And IP are assigned. And now we are going to check the connectivity is finished. Now we are going to check communication. So all ports are up as you can see. Just this port is remaining to be up. Let's wait for it. Yes, it's also up. And all ports are now up. And now we are going to check communication. First, we should communicate this device and this company device. That is it able to communicate with the switch in its own company device or not, in its same network or not. So go to this PC, go to CMD command prompt, which is CLI base, and write here ping. And for example, I want to ping this device. So I will write 192.168.0.4. Is it able to communicate? Yes. Reply is coming from this 0.4 device. For packet sent, for received, and 0% loss. If I want to check with this company device but connected with another switch, not this switch, like I have pinging this device which is from this same switch. Now I will ping it with another device of another switch. So how? Right here ping and 0.6 for example. Yes, it is able to communicate because reply is coming from 0.6 device. As you can see, 4 packets sent, 4 received, and 0% lost. Now let me check with this device, the another company device. So is it would be able or not? No. Why? Destination host unreachable. What does it mean? It means that 4 packets sent, received 0 and 4% lost during communication. It means communication is unsuccessful. So why? Because there is no protocol. We should configure protocol first. How? Come here and write here router rip, write here network, and what is the network here? 192.168 and it's class C, so it would be 0.0. 3 network and 1 host. And another network is first class A, so class A 1 network and the host would be 0. Okay, so the protocol is now up. Now let's configure protocol on this device as well. How? Right here router rep, we are configuring routing information protocol. Okay, so right here network, and after this right here the network of this private network, what is it? Class B. Class B 2 networks would be same and the host would be 0. And right here network, and then write the class A network. So one network in class A, 3 hosts. So one network would be same and host would be 0. And right here is it. And now check it. Is it able to communicate with another company, another device like this one? So now let's check the result after protocol configuration. As you can see the result, request timeout. It's taking time to make it reachable because protocol is configured recently now. It will take some time. Yes, yes, finally we have done. Finally we have done. As you can see, 4 packets sent to another network device and 4 packets received from another network device. 0.6, this one. Which one? This one. And 0% loss. As you can see, our lab is completed successfully. This was a great lab, I think. So let me ping this device to company this device, another company device, another network device. So I will come to this device and I will go to CMD and I will write ping. And what is IP of this device, which is from another company? 192.168.0.5. So it is able to communicate. Why? As you can see the result. Yes, yes, finally, it's going to be communicate with another device. Why? Because reply is coming from 0.5 this device. As you can see, 4 packets sent, 4 received, and 0% loss. So if you want to communicate one device to another device, now you can. So that was too much large lab for this session. For the basic students, I will share this lab as well in the group. Now let me close this lab. But before that, if you have any question in this lab or without this lab, you can ask. You connected switch 2 to switch 1. Can't we connect switch 2 to router directly? Company A. Let me check. You mean that company A, this one, and this is switch 2, we have connected to switch 1. You said, can't you connect this to router? Yes, we can, but there would be a problem. You know what? Then there would be separate network, not this network. And there would be not two networks, there would be three networks. That's why the situation will be different. And we don't want multiple different networks in same company. We want different network in another company. If we would have a same different network in the same company, then why we need this company? We take this company as an example of different network, as you can see here. Okay, I think now you understood. We have just configured the topology, designed the topology according to the situation. But what you have said that can be done. But the problem is there is another situation. What was our task? What was our situation? We have done according to that. I think now you have cleared on this point. We have checked every device that is it able to communicate with its own company device or with another company device. So yes, it was successful as you have watched the result. And Shan Salim said, okay, thank you so much, Shan Salim. But again, I'm telling all of you, we are going to end the session. We perform two labs, one in GNS3 and one in packet tracer. So if you have any question regarding the lab, regardless the lab, whatever question you want to ask, you can ask. If you haven't any question, then our session is going to be ended. You can say clear, or you can say, I have a question, you can ask a question, or you can quit the session because our session is going to be ended now, because our labs are completed, our theoretical section is completed. If you want to do some changes in packet tracer in this lab, so you can ask. So I think you haven't any questions, so let me close the session now. Okay, giving you 1 minute if you have any queries, or you can say clear so we can end the session. So giving you last 1 minute, okay? Because I don't want to make you confused. I want to make you clear in this boot camp, which will be ended after 5 to 6 sessions, because this is session 10 and we would just cover 15 sessions in this 15 days networking bootcamp. So you have only 30 seconds left to ask any queries you have. So now let's end the session. Thank you so much. We will meet in next session. Allah Hafiz. Goodbye.